Let's all do number one together, all right? We have a piecewise function that's called f of x, and we have two pieces to it. So what you need to kind of do is imagine the top piece being the equation y, well, let me change that. Y equals negative x, and imagine the bottom piece being y equals positive x. Now we all know how to graph y equals mx plus b. So let's graph the red one, the y equals negative x. What is the b value in that case? What's the y-intercept of that one, and the red one? 0. So it's going to cross at 0, and from that point we're going to go down 1 over 1. So it crosses at 0, and you're going to go down 1 over 1, and that's your other coordinate. And you could draw a line through that, but I recommend that we just keep using that same pattern of slope of down 1 over 1, down 1 over 1, down 1 over 1, and you could use that pattern backwards to make the line as long as you like. You guys with me? However, what about the domain of this guy? Up on the top part, on the negative x part, it says if x is less than or equal to 2. So I don't want any value that's greater than 2. So I need to erase any value that's greater than 2 on the x. So this dot over here I erase, that dot over here I erase, and at 2, so in other words, any value that's greater than 2 I need to erase because it only wants x is less than or equal to 2. So here's the x value of 2, less than is this way, so I do want to show all of this part of my line, so I might as well graph it. Sorry, it's ugly. And this is a solid dot right there. I should put a solid dot right there. Let's do it in black. Now let's go to the other one. The other one is the blue one. That one also crosses at 0. Put a dot at 0. And then from that point I want to go up 1 over 1, extend it up 1 over 1, up 1 over 1, and keep going with that same pattern. And of course you could go backwards, but what about the domain of the blue one? What does the domain say up there? If what? If x is greater than 2, right? So you need to erase everything that's less than 2. You only want to show the greater than 2 part. So I want to erase this guy right here. That guy. Oh man, I erased the red line. Sorry. There we go. So I only want to go from the x value of 2 from here greater than. So I only want to show this piece of the line. So yeah, it starts right here, and you want to show that piece of the line, and you're done. Wait a minute. Where did I mess up? That should be an open dot, not a closed dot. And of course, I can't erase that anymore. I'm sorry. I put an open dot right there in black. And that's your piecewise function graphed. Now, let's also throw in the twist of stating the domain and range. Okay, so let's say, and I would like you to write it out, say the domain, actually, without this, the domain, you could abbreviate D, of f of x. So I'm saying the domain of all of it, right? The domain of all of this. I'm not talking about this top piece or the bottom piece. I'm talking about the whole thing. And what is the domain? I'm talking about my x values, my x-axis. So do these two pieces, do they go in both directions forever? Yes, they do, right? This red one goes to the left forever. Who cares if it's going up? It does go to the left. And this blue one goes to the right forever. Who cares if it's going up? So my domain, you would say x equals all real numbers. Now, how about my range of this guy? Range is my y values, okay? So my range are my y values. Is there any piece or any part, any coordinate of these graphs that's down here at -6 on y? Down here at -6. Is there? No. At -10? No. At -4? No. Where is this graph at in terms of the altitude, in terms of y's? Where's the graph at? What's the lowest point that you see in terms of y? -2, that's the lowest y value you'll see. Every single other y value is above -2. So when we say the range, we're talking about the y values. And I guess to stay consistent, let's say the range of f of x is y. And we said it has to be greater than, that means up here, greater than -2. So we're going to say greater than or equal to, because it was a solid dot, right? -2. And that's your domain and range. Let's move on to a different one. Let's go to number 3. These are so easy because they don't even have an x value. They're just flat lines, right? So the top one, f of x being equal to -1, we could pretend it says y equals -1. The bottom one, let's pretend that it says y equals +2. Okay, so let's graph the top one, y equals -1. How do you do that? You simply go to the y-axis and you go to -1 and draw a line through it. So here's my y-axis, there's -1, and let's draw a line through it. However, the domain says that you only want to show what? X less than or equal to -2. So you don't want to show anything. This is 3, 2, 1, 0. You only want less than or equal to -2. So you want to start at -2 and continue to the left. That's the piece that you want to show that represents the top one, y equals -1. Now let's go to the blue one, y equals 2. And of course that one is a flat line crossing the y at 2. And you could draw your line. However, you're going to have to erase because the domain says that you only want x values that are greater than -2. So you don't want anything that's less than -2. So you want to erase and just have the open dot at -2, and greater than's to the right, and that's why we only show the right part of this thing. So those were easy because there were constant values. There was no x values in your function. Let's take a look at number 5. That one looks fun. So I want to call the top one y equals -x plus 2. And let me start graphing this thing. Where does it cross the y-axis? 2. Everybody put a dot there. Now what do I do from that point? Down 1 over 1 because of the slope. Down 1 over 1, down 1 over 1. And you could keep going as far as you want. Or you could go the other direction to extend the line as much as you want. However, what does the domain say on this piece? It says what? X is what? Less than or equal to 0. Now, where's less than or equal to 0 on x? It's to the left of 0 on the x number line. So you don't want anything on the right side. You only want the left side of this thing. So I'm going to erase these dots over here. Whoa, not the 0. Again, this is saying x is less than or equal to 0. Here's 0 on the x. This is greater than or 0. This is less than 0. So you only want to show the left side from this point to the left. So your line will be that solid dot going this way. And put an arrow on that thing. Now the next one, it says, let's do it in blue. Y equals 1/2 x plus 3. So that one crosses at 3. And what do I do from that point? Here's a dot at 3. What do I do from that point? Up 1 over 2. Man, you got that wrong. Okay, so up 1 over 2. Put a dot there, up 1 over 2, up 1 over 2, and you could keep going. Now this, and you could go backwards, but this domain says for this piece, x is greater than 0. The condition is that x has to be greater than 0. So you're going to put an open dot because it doesn't have an or equal to. So I'm going to erase this dot and put an open dot right here and draw my line. And ladies and gentlemen, we have graphed our piecewise function. Now, you might be thinking, will it always be disconnected like this? Like you guys see there's space, there's one unit between this solid dot and this open dot. Sometimes the solid dot is inside the open dot and it just looks like a continuous line. So sometimes there will be a space, sometimes they'll be connected, and they could even be separate also. Like there could be a gap between them. Just to let you know. Okay, let's go back and talk about domain and range of the entire f of x function, of the entire thing, right? So what's the domain of this guy? The domain of f of x. I want to say f of x to say the whole thing. So the domain is what? X equals what? All real numbers. And the range is going to be y is what? Anybody? Greater than or equal to 2. Thank you, Jonathan. So I hope this kind of helps. We need to practice. Jumping to number 2. Let's graph the top one. Y equals 2. That's going to be a solid line right through 2, like this. Of course, you're only going to show a certain part of it. X has to be greater than negative 3. So greater than negative 3, you don't want anything that's less than negative 3. And the reason why I'm erasing a little bit more is because it's going to be an open dot at negative 3. Now the other one says y equals negative 5. So the line y equals negative 5 is going to be down here. And it's going to be a line going right through it. Of course, you're going to have to erase because the domain up here says x is less than negative 3. So you want less than negative 3, nothing greater than negative 3. So you're going to erase all this positive, even the 0, all the way to negative 3. And it's going to be an open dot at negative 3 also. And it's going to be going less than, which is to the left. Now, if we're trying to find... Oh, that's ugly, sorry. We're trying to find domain and range. That's disgusting. Domain and range of this guy. Your domain would be x equals... Now... and we're talking about the whole thing here, does it go to the right forever? Yes. Does it go to the left forever? Yes. So you're thinking x equals all real numbers, and you say, but notice that there's an open dot here and an open dot there. That means that x cannot be negative 3. So the only little detail that you have to add on to it is x cannot be negative 3. Does that make sense? How about your range? The range of this guy. What would your range be? Y is greater than 2, y is less than 2, y is greater than negative 5. What is it?
Less than or equal to 2.
So you're telling me that it has coordinates that are all down here? Will you ever have a coordinate with the y value down here?
No.
No. If you're on this one, the only y values you're going to have are what?
2.
And if you're on this one, the only y values you're going to have are what?
5.
Negative 5. So if you know that, write it down. You're going to say the range is either going to be 2 or negative 5. That's it.